Okay, so part B, and that's an interesting one because that sort of has a change between the normal distribution we discussed and a new distribution that appears to be now, and it's binomial. So although you have the answer there, I'm not sure you will be, it's going to be way too easy to follow. So I'm going to go through that example. So Cliff catches 5 trout in an afternoon. Find the probability that at least two of the trout are more than 35 centimeters long and state the assumption. Let's begin with sort of like, the understanding of what we're actually doing here. So I have defined here a new random variable, x, and as x as defined as the number of fish caught that they are more than 35 centimeters long. Now, I haven't written there, and I'm going to write it now, that the variable x is a discrete random variable. And it's a discrete random variable because the way you have to think about it, when Cliff catches a fish, that is going to be either more than 35 or less than 35. So making the assumption that each trial is independent from the previous one, which is not quite true because one less fish is going to be, it will change slightly the probabilities. But if we talk about the large number of fish, then the probabilities, we assume that they remain the same. So this is how we kind of like, combine normal distribution from the part one with the binomial distribution for the second one. So x is going to be the number of fish, as you can see here, that they are more than 35. And the probability of success, it will be from the calculator, it's going to be 1 minus the probability of less than 35, which we calculated with the normal distribution from the first part of the question. So 1 minus 0. What was that? 256. And that will provide us with a 0.44 that I have already written here on the right, and this is the probability of success for the binomial distribution that we're dealing with. So what we have here, we have a binomial distribution. Each trial, each success, each chance of getting a fish more than 35 is the same independently with what was the previous fish, although we discussed that assumption that it's not entirely 100% true. But if we assume that there's a large population of fish, then the probability doesn't really change. That's the understanding. So here I've written down that the probability of at least 2 out of 5 more than 35, it corresponds to the probability of x bigger or equal to 2. And if I go into the calculator, what I want now the menu, and I want the probability, and I want the probability distribution, and I want the binomial CDF, right? Because I'm checking for 2 or 3 or 4 or 5 in 5 trials, right? Because it says at least 2 or more. So number of trials, we had 5. Probability of success is going to be the 0.744, 0.744. The lower bound is going to be 2, because 2 or more will do, and the upper bound is going to be 5, because it's 5 fish or 5 trials. Press OK, put your answer down, which is the 0.98293, and then round to 3 significant figures at 0.983, and right next to it 3 significant figures. And that's a really nice sort of part of the question, because it gives you the opportunity to see, like we discussed in the lesson earlier today, how you can combine the binomial distribution with the normal distribution with a binomial, or combination of different kind of distributions, which is what we really need.